Hello everyone. In this video we'll talk about transmission impairment. A transmission impairment is a property of a transmission medium which causes the signal to be degraded, reduced in amplitude, distorted or contaminated. Impairment can introduce errors into digital signals. Examples of transmission impairments are attenuation, delay distortion, and several sources of noise, including thermal noise, impulse noise, and intermodulated noise. Main transmission impairments are attenuation, distortion, and noise. Pictorial representation. It is important to understand transmission impairments for several reasons. Understanding the source of transmission impairment, like attenuation or dispersion, will enable the user to partially correct for these effects. Understanding the source of transmission impairments, dispersion, attenuation, impulse noise, thermal noise, can also help the user understand some of the constraints placed on the transmission of data and as a result of these effects. Such constraints include the maximum length of network links, the choice of physical transmission media, the choice of encoding methods, and the data rate supported by the medium. Attenuation is a property of transmission medium. It measures how much energy is absorbed or radiated from the traveling signal due to its interaction with the transmission medium. Attenuation is measured as a function of the distance traveled through the transmission medium. The transmission medium absorbs energy because the signal is influenced by small impurities within it. Such impurities have different sizes and distributions depending on the type of medium. Impurities of different sizes affect different frequencies in the signal. The effect of attenuation is, therefore, a function of frequency. The frequency variation of attenuation can be partially corrected or equalized by applying correction based on a physical model. When a signal is attenuated, its amplitude is reduced. The interpretation of a received signal depends on being able to tell the difference between different signal levels. If the amplitude is reduced too much by attenuation, it becomes impossible to accurately tell the difference between the different signal levels, and the information in the signal is lost. To prevent this from happening, repeaters or amplifiers are used. These devices increase the amplitude of the signal by decoding and retransmitting the signal or increasing the received amplitude respectively. By inserting amplifiers or repeaters in the transmission media, the maximum signal propagation distance is increased. This is amplification of the signal by amplifier. Here we have an example. Now this slides talk about uh, the distortion that we have in signal, a kind of transmission impairment. Dispersion is also a property of transmission medium. Signals with different frequencies will travel through a transmission medium with slightly different velocities. Therefore, the signal will be smeared or distorted when it reaches the destination. The longer the transmission medium, the larger the time difference in the arrival times of the parts of the signal with different frequencies, and the more severe the smearing or distortion of the signal. Like attenuation, the physical properties of dispersion can be modeled. Thus, it is also possible to develop an equalization model to partially compensate for dispersion. Pictorial representation of noise. Noise of different types will affect a transmitting signal. Thermal noise, low amplitude random noise at predictable low amplitude is caused by the thermal vibration of the molecules within the transmission medium. The difference between signal levels in a transmitted signal will generally be much larger than the amplitude of the thermal noise. Thermal noise sets a limit of how close different signal levels can be at the receiver. Thermal noise will not usually be of high enough amplitude to cause the introduction of bit errors in an encoded signal. However, impulse noise picked up from the environment can have high amplitude for different lengths of time. Such impulse noise can be caused by interference from other signals in the environment, including other transmitted signals or electrical fields, natural or man-made, emitted by other electrical equipments. The amplitude of impulse noise may reach or exceed the magnitude of the signal. The duration of a pulse of impulse noise may be several times the duration of a single signal. Because of the large amplitude of the impulse noise pulse, it is possible that when added to the real signal, the resultant received signal may appear to have been transmitted at a different level that it actually was. Here we have an example related to noise. We are talking about signal with three levels 1, 0, minus 1. An impulse noise has an amplitude of 1 added to the signal. The resulting received signal will have a level of 0, 1, 2. Now, during the noise pulse, a signal transmitted at level 0 will arrive at the receiver with an amplitude of 1. Similarly, a signal transmitted at level minus 1 will arrive at the receiver with an amplitude of 0. In both the cases, the level of the received signal will be different from the level from the signal that was sent. When the signal is decoded, the resulting value of the data bit will have changed in transmission. A bit error has been introduced in the received signal. Now, talking about throughput, propagation speed, propagation time, wavelength, and Shannon capacity. Now, throughput is the number of bits passing through a specific point or something like an imaginary wall in a second. Propagation time is the difference between the starting time and the ending time. Wavelength is basically the length that we have of a complete cycle. Shannon capacity theorem defines the maximum amount of information or data capacity which can be sent over a channel or a medium. And the formula to calculate this is C is basically the channel capacity in bits per second, that is equal to B, which is bandwidth in hertz available for data transmission, log 2 within the bracket 1 plus S by N. S is the received signal power and N is the total channel noise power across bandwidth B. Thanks for watching.